Hey guys, Travis Gillespie here. Today we're going to be looking at angle relationships. We've been looking basically at problems that utilize one angle, but now we're going to move into where lines intersect each other and we have multiple angles that are created. So let's move forward into measuring and classifying multiple angles. So we have this figure down below, and I'm just going to kind of put it in a better spot so that we can see it. And what we're going to do is look at how angles they connect with each other, and we're going to see how they correspond with one another as well. So below we have these two lines, they're intersecting each other and angles have been created. I see an angle here, another angle here, another angle here, and a fourth angle here. Let's go ahead and just erase all of that information for now. And because of these intersecting lines and the angles that have been created between those lines, some of the angles, they're known as adjacent angles. I'm just going to write that down here. Adjacent. And adjacent angles occur when two angles, they share the same ray and vertex. So here we see a ray shooting out, and this would be the vertex here. So the adjacent angles with this ray would be angle 6 here and the one adjacent to it or next to it. And there are other pairs of adjacent angles within the same diagram. Another one would be angle 5 and the one that's adjacent to it here. We have two more adjacent angles. One would be angle 6 and its adjacent angle on the other side, or again angle 5 and its adjacent angle on the other side. Basically they're angles that touch each other and they share a ray and a common vertex. Cool stuff. So an adjacent pair of angles would be two angles that share the same ray and vertex. So I'm just going to move this screen over just a little bit so that we get a better view of what we're working with. Here we are. Another cool phenomenon that appears when two lines intersect are something called vertical angles. And vertical angles, they're basically angles that are opposite of one another. So here where the lines intersect, I see that angle 5 and angle 6 are opposite of one another. And when two lines intersect and you have vertical angles, these angles are congruent. They're the same size and same shape. Cool, so vertical angles are opposite angles, or angles that are on the opposite sides. And they are the same size, so they're basically congruent. Period, they are congruent. So same size, same shape. Well, if this pair of angles are vertical because they're opposite of each other and they're the same size, well then this other pair of angles look to be on the opposite sides of one another as well, so therefore they should also be congruent. So again, vertical angles, it's when angles are on opposite sides of two straight lines or two intersecting lines here. And they're always the same size or congruent. So let's just backtrack for 1 second. I've got some notes written in red. some notes written in green, and the red represent the adjacent angles, the green represent vertical angles. So I'm going to go and just highlight a couple of adjacent angles here in red. So this angle, along with angle 6, are adjacent. They're next to each other. They share the same ray, and the vertex they share the same vertex. Also on the other side, angle 5 and the angle next to it are also adjacent to one another. So another way of looking at it is these are two angles that are next to each other along a straight line. Now I'm going to go and highlight in green pen a pair of vertical angles. So I see that angle 5 and angle 6 are opposite of one another. Therefore, they have to be vertical angles. They're the same size, same shape. Cool, let's go to another problem.